Good morning, grade 9. Today we will continue with chapter 7, Geometry. Please open your books on page 31 in order to solve number 4. In number 4, we have in the given, in the figure to the right, C is a semicircle with center O and radius 5 centimeters. BD is the diameter of the circle C, and A is a point on the circle C such that AB equals 6 centimeters. In part 1a, what is the nature of triangle ABD? ABD is a right triangle at A since it is inscribed in a semicircle of diameter BD. In part B, we have to calculate AD. In triangle ABD, which is right at A, we can use the Pythagorean theorem. Then, BD squared is equal to AB squared plus AD squared. With BD equal 10 and AB equal 6, then 10 squared equals 6 squared plus AD squared. Then AD squared is equal to 10 squared minus 6 squared equals 64. Then AD equal radical 64 equal 8 centimeters. In part 2, the perpendicular through A to BD intersects it at H. Prove that the two triangles AHB and DAB are similar, and deduce that AH equal 4.8 centimeters. So first we have to prove that the two triangles AHB and DAB are similar. We have AHB equal DAB equal 90 degrees and ABH equal DBA since it is a common angle. Then AHB and DAB are similar. We still have to deduce that AH equal 4.8 centimeters. So we have to write the ratio of similarity. So we put the two triangles AHB and DAB and we write the ratio of similarity. AH over DA equal AB over DB equal HB over AB. So AH over DA, which is equal to 8, equal AB, which is equal to 6 over DB, which is equal to 10. And we make a cross multiplication, so we get 10 AH equal 48, then AH equal 4.8 centimeters. In part 3, the tangent at D to the circle C intersects the line BA at the point E. In part A, in the two triangles ABD and BDE, write the ratios equal to tangent B, then calculate DE. As a reminder, the tangent of an angle in a right triangle is equal to the opposite side over the adjacent side. So, in triangle ABD, which is right at A, tangent B equal AD, the opposite side, over AB, the adjacent side. And in triangle BDE, which is right at D, tangent B equal DE, which is the opposite side, over DB, which is the adjacent side. We still have to calculate DE. Since we have the same tangent B, then AD over AB equal DE over DB. So 8 over 6 equal DE over 10, then 6 DE equal 80. Therefore, DE equal 80 over 6 equal 40 over 3 centimeters. In part B, determine the measure of the angle B rounded to the nearest degree. From part A, we have tangent B equal AD over AB, then tangent B equal 8 over 6 equal 4 over 3. Then, the measure of the angle B is equal to tangent minus 1 of 4 over 3 equal 53 degrees. In part 4, let P be a point on BD such that DP equal 4 centimeters. The parallel through P to the line AB intersects DE at Q. Calculate DQ. In triangle BDE, we have from the given PQ parallel to BE. so we can use the Thales theorem. Then dP over dB equal dQ over dE equal PQ over BE. Then dP, which is equal to 4, over dB, which is equal to 10, equal dQ over dE, which is equal to 40 over 3. Now if we make a cross multiplication, we get 10 dQ equal 160 over 3, then dQ equal 16 over 3 centimeters. In part 5, denote by R the translate of P under the translation with vector QE. In part A, we have to show that R is a point on BE. In order to show that R is a point on BE, we have to prove that the points B, R, and E are collinear. We have from the given vector PR equal vector QE. Then we can deduce that PQER is a parm, and the opposite sides in a parm are parallel. Then ER is parallel to PQ. And we have from the given BE parallel to PQ. So we have two lines that are parallel to the same line PQ and with a common point E, so we can deduce that ER and B are collinear. And if they are collinear, then R is a point on BE. In part B, the line PR intersects AD at the point J. Prove that BJ is perpendicular to DR. In triangle BDR, we have RP parallel to DE, since vector PR equal vector QE, and two equal vectors can give us two parallel lines. And DE is perpendicular to BD, since ED is the tangent to the circle C at the point D. Then RP is perpendicular to BD. If two lines are parallel, then every perpendicular to one of them is perpendicular to the other. Then RP is the height relative to BD passing through J. We have also DA height relative to BR passing through J, since ABD is a right triangle at A. Then J is the orthocenter of triangle BDR. Therefore, BJ is perpendicular to DR, since it is the third height. Please don't forget to write the exercise in this video on your notebooks and to review the exercise. Thank you so much for listening.